Hello students, welcome back to physics class. In the previous video we have seen the chapter 2 physical quantities and measurement. In that we have seen density, the formula to find the density and how to find out the density for a regular solid, and then we have seen vessels for measuring the volume. So in that we have seen measuring cylinder, measuring beaker and eureka can. In this class we shall see using all those vessels how to measure the density of a irregular solid. To determine the density of an irregular solid, we have to measure its mass and volume. The mass of the body is measured with the help of a beam balance. To measure the volume of a solid, we use the displacement method. That is, a solid when immersed in a liquid displaces volume of a liquid equal to its own volume. The measurement of volume of an irregular body by displacement method can be understood by the following activity. We'll see one by one. So when you want to find out the density, you should know the formula, that is mass by volume. You should know mass and volume. For example, you take a stone. First thing what you have to do is, you have to measure the mass of the given solid, or here you are taking stone. So using a common beam balance. So you will measure the mass and note it as M is equals to, okay. For example, the mass of the stone is 75 grams. You can measure the mass of a given solid using a common beam balance or a spring balance. The next step, take a measuring cylinder, fill it partially with the water and note down the water level. That will be V1. So here V1 is equals to 50 ml. The initial level of the water is 50 ml. Next, you tie the given solid with a thread and gently lower the solid in water contained in the measuring cylinder. Then take care that no water splashes out or spills out. Note the level of the water again, that will be V2. So here what is V2? The final level of the water, 78.8 milliliter. Then now we are going to find out the difference between the initial level of the water and final level of the water. So how will you find out the difference? By subtracting it. So the volume is equals to final level minus the initial level. The final level was 78.8 milliliter and the initial level was 50. So when you subtract, you get 28.8 milliliters. So here you have measured the mass. Mass is equals to 75 grams. Volume is 28.8. So you have measured it in milliliters. So when you convert it, it is centimeter cube. So centimeter cube. Then you know the formula to find the density. So density is equals to mass by volume. So substitute the value of mass and volume. So 75 divided by 28.8 gives you 2.60 gram per centimeter cube. Okay, the density of the given stone is 2.6 gram per centimeter cube. This is how you will find out the density of an irregular solid using the measuring cylinder. Next we will see how to determine the density of an irregular solid using a eureka can. So what and all do we need for this experiment? Measuring cylinder, a eureka can, beaker, irregular object, thread and water. So let's find out the density of an irregular object. The first thing, so you have to use the weighing scale and measure the mass of an irregular solid. So what is the mass of the irregular solid? It is 9 grams. So you have to note the mass of an irregular solid. Next, tie the irregular solid using the thread. Then fill the eureka can with the water. So you will fill the water until the water comes out of the spout. So pour the water into the can until it starts overflowing through the spout. When the water has stopped dripping, remove the measuring cylinder and empty it, dry it and again place it under the spout. Next, take the irregular object and immerse this irregular object gently into the water contained in the Eureka can. The solid displaces water equal to its own volume. Then you collect the displaced water and measure the volume of the water which is displaced by the irregular body. Volume is 4.5 ml, that is 4.5 centimeter cube. So you can find out the density using the formula mass by volume. Now you know what is a mass. Mass is 9 grams and volume is 4.5 centimeter cube. So when you substitute in the given formula, you get 2 grams per centimeter cube. The density of the irregular solid is 2 grams per centimeter cube. This is how you will find out the density using the Eureka can. Next, determination of the density of a liquid. So you have seen how to use the measuring cylinder and Eureka can. Now to determine the density of a liquid, say milk, oil, etc., its mass m is measured by a common beam balance and its volume v is measured by the measuring cylinder. Then density is calculated by using the formula density is equals to mass by volume. Let's take an example of determining the density of milk. The first one, take a beaker, measure the mass of the empty beaker using a common beam balance. You are going to measure the empty beaker using the common beam balance. Let the mass be m1 gram. The next step, now take a measuring cylinder and pour milk into it to a certain level, say 50 ml. Thus volume of the milk is, how much have you taken? It is 50 ml. So we can write it as 50 centimeter cube. Next, transfer the milk into the empty beaker. Measure its mass again. Let the mass of the beaker with milk be m2 gram. Now find the difference, m2 minus m1, which gives the mass m of the milk. Thus mass of the milk m is equals to m2 minus m1 gram, that is m. Okay, let it be 51.5 grams. Next, the last step, calculate the density of the milk using the following formula. So you know the formula to find the density, that is mass by volume. Then mass is 51.5 gram and volume is 50 centimeter cube. That will be equals to 1.03 gram per centimeter cube. Next, density bottle. Okay, what is this density bottle and how we have to use it? Let's see in this. So a density bottle is a specially designed bottle which is used to determine the density of a liquid. So this is the density bottle. It is a small glass bottle having a glass stopper at its neck. The bottle can store a fixed volume of a liquid. Generally, the volume of a bottle is 25 milliliter or 50 milliliter. The stopper has a narrow hole through it. When the bottle is filled with the liquid and the stopper is inserted, the excess liquid rises through the hole and drains out. Thus, the bottle always contains the same volume of the liquid each time when it is filled. Okay, this is the density bottle.